Good day, good morning, good evening, good evening. This is Brian from quantlabs.net. So today, over the last 5 years, pretty close, damn close to 5 years, I've been studying different trading systems, building different trading components, and here I am again, pretty well starting from scratch. Now, this is a piece of software called DIA, and it's just a computer diagram, something like a Visio, just so we can go over the components of a trading system for automated trading or even high frequency trading. I'm just going to show you the different options we have and what we're looking at. Alright, so obviously first we need to store data. So this is what this little data thing represents. So this can be a database of whatever kind, okay? So we call this database 1. Or I'll just call it a SQL Server database. Now, I'm not going to go into particular flame war on what works and what doesn't work, but I just want to make sure that we understand what we're dealing with here. So we can have a SQL Server database, and again, this is what I'm thinking of doing. Golly gee, please work. No, maybe a hand here, as I have wonderful good experiences with these tools that I've never used before. Oh, there we go. Okay, so I'm going to call this particular database NoSQL, okay? Don't ask me the details of what particular database this could be. I'm going to explain that in a minute. But we'll just leave it as a NoSQL database, and we'll have this other database here as SQL. Now, the NoSQL database is something we'll leave at saying high-speed database for all you non-technical people, because I know you're out there probably watching this. Now, there's numerous options that are available. There's Redis, there's MongoDB, so there's just basically NoSQL, no SQL language that comes with it pretty well, that you can use for high-speed in-memory data processing. Ultimately, you want your own in-memory database that you build, that you own, and that you optimize, just basically for time series. So obviously your time series could be tick or bar data, like 1 minute, 5 minute, 15 minute, or an hourly or end of day data, right? So we could store both these in here. Now, when I'm saying database, I'm only really referring to just data for a pure core analytics system. For some kind of trading algorithm or trading idea or trading strategy that will work against this database. Now, this is where it gets really confusing. I'm just going to put this out there for now, okay? I'm going to say we got the Linux world, and then we also have our Windows world, okay? If you know me, I've been bouncing back and forth between these two for a very long time. And in here, there's various different programming languages that are specific to those operating systems. This one's obviously commercial. This one is open source. And there's just so many choices in between. Now, I've written a lot of components that pretty well work mostly in Windows, okay? Because of the tools, the applications all support it in Windows. And then there's Linux, and then there's different distributions of Linux. Let's not get into that. I mean, there's enough confusion going on here, but I'm going to try to break it down as simply as I can. So we have Windows and Linux. Now the question is, we'd start then getting into things like server side and client side. Okay? Now, if you were to look at the world of Linux, when I say Linux, we have a server side, and then even in the world of Linux, we have also our desktop. So you have different editions for each Linux version. You have a server edition, and you have your desktop version. Desktop usually just includes the front end, the graphical user interface. The server side is just stripped down with bare bones communication and some other necessities for the Linux system to run. Linux is more basically like this, where you have your Windows and all that stuff going on. So let me get rid of these options here. And then, of course, on Windows, we have the same idea. We have Windows 8, Windows 7. That's pretty well your desktop version of Windows. And then in Windows, for the server edition, you'll have something called, well, one day I'll get this correct. Windows Server 2008, 2012, one of the two. So obviously you're going to want to work with the newest version. Actually, the Windows version of Server 2012 is quite good. Now, you've probably seen one of my videos on that. Okay, so that's the breakdown there. And then we further get down into the languages. Okay, so I've introduced you to the client and the server side. This is what I'm looking at. Let me just draw a line here. How do I draw a line? Polyline, baseline. I don't know, let's just choose this line. See if this works. Okay, so this is how it's going to work. Well, let me just swap these two words here. Okay, there we go. That looks better. So, as I said, this is how I'm planning to architect this system here. This is our server side. Okay? This side is the client side. Usually, there's different ways for this side and that side to communicate with each other. What I'm choosing, actually, let me just put here, you got Erlang, which I'm really leaning towards, right? Or a really popular library called 0MQ, or better known as just pretty well 0MQ. Now, if you know me, I've worked with 0MQ. It's really good, but there's some difficulties with it. I'm not saying it's not good. It's just, you know, for my needs, well, this is where Erlang comes into play, into the picture. I've just really honestly have just discovered this about a week ago. It's open source, it's rock solid, it's been out for 25 years, courtesy of Ericsson. Really designed for the telco world. And go and just check out my blog on Erlang. Okay? So basically I'm using Erlang as one way for, let's say, this side to talk to that side and vice versa. Right? Okay, so we have our server components and our client components. So let's talk about our client components. Now, the big one that I'm talking about is your charting. Okay? There's so many options in charting. I could go on about blah, 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 blah. Let's see what options we have here. Okay, we've got DevExpress. We've got side charts. We got I'm probably lightning charts. And then my favorite that I've just pretty well discovered again is infragistics. Okay, I hope I got that right. Something like infragistics. I'm the world's worst typist, so please excuse my mess here. All right, so let's go through each one. DevExpress is good for mobile. And again, these, because it's client side, what we're dealing with here, just to add further confusion, .NET programming, or the .NET framework from Microsoft. This includes languages like C#, F#, VB.NET, ASP.NET, but let's eliminate, again, the confusion. All we really care is not that language and not this language, okay? We care about these two languages, okay? And kind of in a way you can use Visual C++. That's a cool language, but the problem is C++ is cross-platform to Linux, cool. But Visual C++, well, there's different flavors of it since it started many years ago, so in a way it's kind of bastardized, but let's just call it C++, so that that little guy can talk to the other side on C++ on the server side. Oh, I hope I'm not confusing you, but again, this is why I got diagrams and all these things going on. So let me just try to take out this right here. Oh, let me just get rid of the entire thing. Okay, so there's that discussion, right? So some of the languages. So all these components here in charting are all done in C#. Now, if you haven't seen my video on charting, I got many actually, but the one I'm most likely going to go with is infragistics. Why? Because okay, let's screw that. Infragistics has two apps. One called Financial Dashboard, and the other one, the Equity Trading Applications. The Equity Trading Application is really good. Okay, again, do a search on my blog to see it, and you'll see that in action. It's pretty well on par with something like from Bloomberg. That's all cool, but guess what? That application is going to, I've never looked at the source code. I played with a program, but that program or that application is going to kind of run off of, actually, remember I'm just doing this on the fly, so forgive me. Well, that little guy, that charting, that infragistics, golly gee, why can't I work? Is going to work off of this guy, SQL Server. So that application as is, the demo that I show, I'm sure this charting, because it's with the data, is going to work off of SQL Server. And it's going to have a schema and all the tables and all that. It's going to be having its own mapping, most likely off of SQL Server. And that's cool for now. But I'll get back into that in a second. So that's kind of important, okay? So that's why I've included the client-side charting. It's pretty well its own self-contained app with source code. Talked about it. With charting and as a front end. And that's something I'm really leaning towards in doing. Okay? So there's that, right? So initially we had Windows Server, SQL Server, how do you house the data? We don't know yet. But I'm just trying to give you an idea of what I'm thinking about on the architecture side. But this charting is definitely going to be the way. I was really impressed with it. Now in today's era, we've now have things like mobile, right? So we need to consider stuff like that. So again, it brings us back to the DevExpress and infragistics. So how do we get that front end in the charting, the different apps, so that they can be served up in an iPad, an iPhone, an iOS, Apple device, or an Android? Well, all these libraries do the same thing and serve up your data and through some sort of a charting front end on those devices. But again, that's really minor. But I got to think about stuff like that, right? So I have to choose well on that. But one of the two will work fine. But infragistics looks really good. And again, with the infragistics, it has a lot of business potential, I guess you could say. So that's our charting. So again, remember, on the database, what we want are these databases to talk to each other, okay? In the Windows and on the Linux side, right? So we want them to talk to each other. Now, that's all cool. Here's the advantage of doing it this way, I think, I hope. Woohoo! This SQL Server is not all that critical for speed, okay? I'm trying to design this system with high frequency trading in mind. It's not critical. It's not do or die, but this is the best I can get it at. From a quick to market approach, right? So that's kind of the system I'm looking at with the C# front end and maybe being able to extend it into the likes of charting, okay? So now here comes the complicated part. Let's talk about trading ideas, right? And this has got nothing to do with the server and the client. I'll come back to that in a second. But these are all the options that you pretty well have for trading ideas, what we call prototyping your trading idea. We have my favorite, MATLAB. Okay, I played with R, then we get into Python, then we get into FSHARP, which is really exciting. Now, because with FSHARP, it's tightly integrated with the Windows.NET. So that's really nice. So if you haven't seen Visual Studio, that's a really nice environment to play with. And you can go up against the data in your SQL Server. So it's really, really nice. It also includes a lot of out-of-box concurrency, parallelism, but let's not go there. We don't want to confuse you, of course. So FSHARP's fairly new, but it gets you up and running fairly fast. So again, I said that speed is somewhat critical, so we want to be cognizant of it. Very good option. We did a presentation a few weeks ago from Phil Trelford on FSHARP, and you'd think I'd be like, yeah, I'm sold. I am sold, don't get me wrong. But let's go on to the likes of MATLAB and R. Out of all these, I would easily put MATLAB as my favorite. If you've not seen MATLAB, damn, man, you are missing out in the world. Let's talk about it in a little bit. Okay, with MATLAB, you can take your trading idea in your MATLAB M scripting language. So you can have an M file. So this could be your trading idea. There's so many tools and GUIs and front-end stuff to get you there really fast. There's so much. You can go crazy with it. But, of course, that comes at a cost. But here's the question you need to ask yourself. Is the cost of developers, doing it yourself, time, pulling your hair out? That matters. So you have to factor these sort of things into or consider it. So with that, under the world of MATLAB, we have our M file, right? So we can easily convert that into C or C++. I shouldn't say easily, as long as you're compliant with certain workflow that it provides, certain functions in MATLAB do and do not run, or are not compatible, not part of that code generation process. We also have 100% compatibility, supposedly, with other toolboxes called through Java to connect into Java. We'll get into Java in a little bit. Called Builder JA. Okay, so that enables you to take your MATLAB M scripts and then be able to convert them into, it's not Java, but you can have a Java application read those components through this Builder Java toolbox. Now it doesn't stop there. We have Builder and E. Yes, I am aware of the spelling mistake. Thank you for considering that. We have another one called Builder NE. That's the .NET one. So that enables me to take that M script and then be able to talk to it with .NET in mind. C#, pretty well F#, do a wrapper into C++ and that. So that's another option. Very nice, as Borat would say. Then there's a more recent one called Production Server. This one's kind of cool. So you can set it up like a Apache server, like a web server, and have your C#, your Java code connect into this production server, hosting your M script through some form of generation, code generation or whatnot, translation to get it compatible and served up in the production server. And now with the latest additions, you can take your Python code and talk to your MATLAB code through the production server. This is all fairly new. That's in the new version of MATLAB 2014. Oh, and does the goodness stop there? Hell no. Let's add one more. Are you confused? Again, watch the video. Rewind. We have Simulink. If you have not seen Simulink, woo, you're missing out. So if you ever want to go high frequency trading via a hardware board like a FPGA, this is awesome because you can take your MATLAB trading idea through a MATLAB script, or you can visually build it in Simulink and code generate it using C or C++, or code generate it into HDL, which is called a hardware description language, and that opens up you to other boards like Altera and Xilinx, which are the pretty well standards for FPGA for high frequency trading. So that's the beautiful world of MATLAB. What I really love, but unfortunately a lot of people cannot afford probably the typical configuration at that. It's going to cost you about 125 grand. But here's the advantage. If you ask your coder that you want to hire on an ongoing basis at least $50K, a year, they're still going to have coding errors. And to maintain the code and to maintain that developer. But guess what? Guess what? You're now held hostage to a developer or a developer team. So when you factor that 125K over time, that's damn cheap when you're quite possibly eliminating the cost of coders or a coding team. So I want people to realize that advantage. Now, the other option that I played with is R. R is really good. Now, let me just open up. Let's talk about R. Here's some advantages. Of course, it's free. But without this RStudio, I'm going to be honest, without RStudio, this thing would be useless. I mean, it has the package management's awesome, and blah, 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 blah. You know, it's awesome management, and that runs on any platform, Mac, Windows, and Linux, which is quite good. Problem with R is the compatibility of all the packages. Some don't play nice with each other, okay? And you gotta go through this hell of translation from this data object to that data object so they can talk to each other. Not a fan of that. Another big disadvantage with R are when I used R, there's 2.15. Then there's R 3. We'll just leave it at X. So I have my R scripts written in 2.15 and they're not backward compatible to 3. So that's the scary thing I do not like about R. I absolutely hate it. And that's a big concern for me. Okay, so that's one reservation with R. Okay, so you know what? I'm going to talk about FSHARP from what I understand. I've never played with FSHARP to a level of degree that I have with MATLAB or ARP, but I'll give you my viewpoint from my research with and having a really knowledgeable guy like Phil Trelford talk about FSHARP. FSHARP is very powerful. I've talked about it already that you can easily integrate it into your .NET framework, which is awesome. And the way Microsoft's going right now, I call it maybe desperation, I don't know. But they're trying to open source the .NET framework and have it compatible with Mono in the Linux world. From my perspective, that's kind of something I wouldn't go with. Why do you need that extra layer on top of an operating system to take your components built in Windows in .NET and try to run them in Linux? That's just another level of complication I really don't want to go through. And of course, that's going to most likely affect speed. They say it won't, but no offense, I really don't want to go that route. Something I wouldn't consider. But FSHARP's nice. It has some concurrency built in. That's very nice. I got to tell you, charting and some really, really powerful, cool stuff. But one of the big features of FSHARP, the big one, it seems to be compatible with R. So you could take your R scripts and then house them in an FSHARP script. And don't forget with FSHARP, you can then have FSHARP talk to a lot of your other .NET applications, wrappers. Basically, they can all talk to each other in the world of .NET. And it's fairly not hard to do that, which is really, really nice. That's why I like my .NET stuff. It's beautiful. It's awesome to run in. And that brings us to that, what I call the mystery child of Python. Now, I don't want to go on here and have a bitch fest about Python. That's not what it's about. But you probably hear me all the time poo-poo Python. Now, Python's like, that's where the cool kids are. That's where the cool development in the world of quant, trading ideas, and all this stuff is going on. Okay, let's be honest. There is trading system built in Python. It's free. It's open source. It's cross-platform. Compatible. Get that. And then that's why I always keep coming back to it. But running between the two major versions of 2.7 and 3.3 is pure hell. I don't know if 3.3 is compatible with 2.7 scripts like it is in R. I don't know. I'm not an expert. I'm sure other people are. But yeah, last night we had a discussion about different programming languages, and I kind of asked about that. But there seems to be a big camp is pretty well in 3.3. And with a person on that call did seem to be in the 3.3 camp, which makes sense because that's the latest version. And that's the version I'd probably go with if I was to choose Python. Now, as I said, you want to be in the cool party. And that's where the world of Python really is. There is compatibility with C. there is compatibility with that Erlang. Oh, remember that Erlang we just talked about here? We'll talk about that in a second. Okay? But there is that. But again, these are all theories if it works or not. And you know the world of open source and the world of free, it's full of surprises that don't work in your favor. And then there's just tons of other cool stuff that looks cool, but getting it up and running was always a challenge in the world of Windows. Well, guess what? I got it running hassle-free in Linux and Ubuntu. Oh my God. Now I'm like, oh, Python could be the way. Who knows? So it's kind of like answering a lot of my needs. Yes, we've talked about MATLAB, but it's like Python, it's, you know, I'm like, whoa, I'm doing a complete 360 here. I realize that, and welcome to my world. So there's that. And then you have obviously the huge advantages that come with Python, be it the big libraries. I've seen NumPy, SciPy, what else? Pandas and all this, and this IPython. I've never worked with it, but working in the world of Linux, that's really opened my eyes over the last couple of weeks. So putting that out there about Python. So these are the pros and cons of each of these 4 major prototyping languages. And then of course there's D, which looks cool, but nobody's using D, but it's a cool language, right? So that's where we're at. So hopefully you understand my logic thus far with all this research. Now, let's talk about Erlang. Erlang's a very, very cool language, okay? Erlang can be, remember we talked about the communication between these two? The server side, maybe the databases, doesn't matter what language you want, whatever you use. The world could pretty well revolve around Erlang, and here's why. Erlang has what I call mission critical. Okay, it has a shell or server that it's so amazingly solid. It's rock solid. From what I'm reading, this is why Ericsson wrote it. It's in the world of telecommunications, mission critical stuff for a lot of corporations. And they wrote this language for the PBXs and switches, and that's where Erlang came from, that world. And you can probably put that into the world of trading. Okay, again, mission critical. But I have not seen anyone really talk about it a whole lot. Maybe I missed the boat on that. So that's one big advantage with Erlang. Now the other thing is it's got the concurrency built in. Okay, I love it. Concurrency is important to me. Multi-threading, all that stuff going on, and it's really easy to work with. It's all housed. You don't have to worry about it. All that plumbing is built in as part of the Erlang server, I guess you could call it. You just build it's all like a scripting language built around Erlang. So that's a huge advantage. I mean, huge. Parallelism concurrency is a big one. It also includes all the necessary plumbing that comes with that. I'm talking about heartbeat, failover. All that is built into this out-of-box, kind of ready to go Erlang. And when you start looking at some of the other cool stuff that you can do with Erlang, things like, I just put up today, I didn't even see it. You can visualize all the processes that go with Erlang. I mean, it's awesome. I'm pretty well sold on Erlang, okay? I'm really sold as being the glue between all of this stuff. The databases, the Windows, the Linux, all that stuff, okay? So there's that. So Erlang, I'm pretty well sold, like, hello, you know? So let's get into the world of Linux. Now, let's talk about Java a bit. Well, let's talk about all the different languages here. One thing people need to understand about Java, the world of Linux, okay? The concepts of this huge, call it a flame war between the Linux haters of Microsoft, and back in the day, well, we don't care about you, Linux, we have our own thing going on. Well, guess what? 2014, there seems to be this shift that out goes the old guard of Ballmer and Bill Gates, and in comes the cool dude, Satya Nadella. And pretty well what it comes down to is that the world moved off of Windows and Linux or Microsoft, and has entered in the world of open source where you can build some pretty good stuff for server edition, whatever you're building in Linux, and with a lot of open source stuff. So I think that's really changed Microsoft. So Microsoft probably got scared, or whatever you want to call it, and they're also losing in the world of mobile, right? And that's where Linux survives. You look at Python. Doing it in Windows, for me at the time, was kind of challenging, but guess what? In Linux, it was just easy breezy, APPT, install, boom, and you're up and running after a couple of lines. Like, that is a huge deal to me. Alright, so I'm coming up to half an hour so far blabbing in this video. Wow, there's so much to this, but this is not easy stuff, folks, so we know that. Alright, so hopefully we cover enough of the Windows and the client, the desktop. Let's just put it this way. I really think that Windows is here to stay in that area. I've not talked about Office. I've not talked about the capabilities of Excel as the front end. And there's so much to it that, I mean, it's just, let's deal with it. That is the world we will live until the day we die, okay? So I've talked about the charting on the client side. That is what I'm looking at. So up comes the server side. So we got factors to consider like speed, cost for licensing, maintainability. Okay, we have I'll just call it interoperability between different languages, and this is pure hell. Okay. You can go on and on about it, but with Linux, and I'm talking about Ubuntu now, okay, as a decent desktop edition distribution to work with, you can get up running pretty fast. So that brings me to the open source server-side trading languages. Of course, we have the granddaddies, C, Java, more of the newer languages, I'll call them, even though it's Python, R, which I won't really talk about, Erlang, what do we all got? Scala, list goes on, right? Let's talk about these guys right here. C is awesome, C and plus is awesome. Complicated, these languages, it's a tough thing to maintain. Okay, let's just leave it at that. Memory management, garbage collection, it's a challenge, but they are critical for the nerve center of the piping between your execution, your trading. That is critical for analysis, number crunching, for if you're going to use GPU to speed up things, or just pure brute force databases in memory. Again, like a new SQL solution. These are really critical. Now, there's always the flame war between Java and C++. So let's talk a little bit about Java. Okay, because Java, well, people may ask me about my experience. C, I know inside out, okay? Like, let's deal with it. I've worked with it under the Kerningham and Ritchie world years ago. I've been programming for almost 30 years, folks, so I'm like no chump at this, right? So I know C really good. Now, memory management, I know double pointer, all that stuff. We're not going to get into that. It's kind of hairy for a lot of people. Then there's a world of C++ that, classes and all this object-oriented stuff, that really can confuse people. Coming from the world of C to C++ for me was a huge shift. That's where I kind of went all over the place, but then I ended up in Java. But these two languages are important, and they're never going to die. Same way with Java, but let's talk about Java. Okay, when Oracle came along, when Sun owned Java, open source, under the world of Sun that created Java, life was good. Java 6 up to Java 6 version 6, it was awesome. Okay, no complaints. Oracle came along, okay, and brought out 7. Oh, what a goddamn mess. Okay, it was just awful. Not a good transition. And that's where I kind of moved into the world of Windows and C# and all that, and fell in love with that stuff. And MATLAB. Now it was about 5-6 years ago, 2014. Okay, so now we've talked about Oracle 7, but we're at now Oracle 8. Sorry, Java 8, and they're now talking about Java 9. Okay, I think for Java to stay relevant against with all these other languages, Oracle needed and understood they had to make some pretty big changes and improvements. So Java 8 came out. The big thing in Java 8 was Lambda calls. These are important because, you know, you can hate on all you want about Microsoft, okay? These are the guys that started Lambdas, okay? Lambdas was created years ago in C#. Lambda calls are basically nice and easy calls that you can call a database, whatever it is, or like a repository of data, and just do cool stuff with it and speed stuff up. That was a big advantage of C#. So they've introduced that feature into the world of Java 8. Okay, big advantage. Now, there's some other stuff I've really not paid any attention to. I'm sure there's some cool stuff in that language and Java, but let's do this. Okay, so Java 8. They've worked on, what am I trying to do here? Oh, okay, I guess I don't need to talk about Java anymore. All right, so that is a cool thing. Now, another big limitation is your broker, okay? A lot of people, for trading, the broker dictates a lot. So let's talk about brokers for a little bit. We've got interactive brokers, who are the big automated API dudes. So the three options that you were always given were Java, let me do this way, just Java, C++, which is really Visual C++. We'll leave it at VC++, Visual C++ for .NET Windows, and .NET. Those are the only APIs that you had in interactive brokers. So where I'm going with this, with interactive brokers, is Java. Now, that's for all your assets, I would assume, for equity, let's say, or stocks. Then we have Forex brokers. There's not a lot of options, and this has been dicked around for the last few years. But, you know, talking to Awanda as a broker, guess what? They have two APIs that you can work with. There's the REST API and Java. Okay? Now this is coming from the broker itself, Awanda. No different than what I just showed you with interactive brokers. So we're not going through some third party, here's my implementation how to work with interactive brokers, like in the world of Python. We're dealing with what interactive brokers supplies you. This is what Awanda supplies you as well. So that brings me to Java. Now, if you go REST, I understand that REST is okay. It's slow. It's slow. I can't say the same thing about Java, but Java is my better option. And as I said, when you're working with Java 8, which I've got reports from we'll just leave it, highly reliable resources. If they say it's fast, it's fast. I trust them, believe me. So I'm not going to sit there and argue with people like that. So that is covering my world in Java, okay? Now, a lot of people, and then this is the very, very first time I'm talking about HFT brokers, okay? A lot of people don't know one, but it's called Lime. There's only two options in their APIs, which I have. I'm not going to release them, I'm not going to talk about it, but I'll say this. C++ or Java are the only ways to go through Lime through an HFT broker, okay? And again, it's only in the world of Linux. You see where I'm going with this? Everything that you do for trading applications with your own source code pretty well comes down to your broker, okay? So let's just say we got LMAX, we have IB, Interactive Brokers, Awanda, and let's just put it out there, Lime, okay? All of these guys can be supported in the world of Windows through Java or .NET. But this one, maybe one day I may choose to go HFT. Talked about lots of times, believe me. For me, I get lots of opportunities coming my way where people want to throw literally 8 digits my way. But I have to, whatever I design, whatever I work with, I have to go in with this mindset that HFT needs to be considered. So Lime is one of them. And again, I've just talked about it. You got all your only options are C++, Java, in Linux. So guess what? That's my limitation. So everything comes down to Java, okay? Java, 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 okay? Especially with the improvements in Java 8, okay? That's what I'm looking for. So what does that mean? Well, if I'm going to work with Java, I have IB covered, I have Lambda covered, I have LMAX covered as well, okay? Every single of these brokers, especially LMAX, when I first started talking to them, they wanted me to go Linux and Java. IB, they're more Windows, but you can do with Linux on I think you obviously can use Java on IB. Okay, and I've gone over a lot with the TWS, the Trader Workstation, which is quite nice. Okay, in Windows, I got courses on that if you're interested. So that's where we're at. Everything's driven by the broker. Okay, people need to understand that. Okay, so that brings me back to all these languages that we talked about. We got C++, Java, and C. So obviously, in this list here, Java is good for my broker, right? Then we have our prototyping languages. Remember we talked about those? Python, R, what was the other one? R, Python, all that. So that's kind of covered off, but we have to figure ways for each language to talk to each other. Well, guess what? That's where Erlang comes into play. Because guess what? Erlang can be called, from what I gather, through a library called PyErl or something like that. I think that's the name of the package. Again, I've not played with this stuff. C++ can be natively called, and Erlang can natively call C as well. But the cool thing is for my Java, I think it's called I can't remember, but there is a way to call Java from Erlang, okay, and it's right on the Erlang site. So that is a safe way. And I just posted other videos. There's other options as well to do that, and that's very key and critical. Now, let's talk about Windows. What are options for C# or whatever language to talk to Erlang? There's lots of options. There's some immature libraries, one called I think OPT.NET. That might be kind of immature. There's a new one coming, open source again, but again, these are not options, okay? So that takes the .NET option kind of pretty well off the table outside of socket programming, right? Or doing it through a port, or doing it through ODBC, or doing it through a Windows service. Well, guess what? None of these are great, because now you're taking away the advantages that you want with Erlang out of box. When you go through, as I said, let me just type those again. So if I want my C#, if I want my C#, my diagram. So if I want my C#, let's say, to talk to Erlang, as I said, I gave you what, 4 options? We have the op.net option, and this new one, new API library. Those kind of are not gonna work. I don't know. I'm not comfortable with these third-party, who knows what. There's ODBC. So we set up Erlang as a database, and through the Windows features of Windows, through ODBC, which is really database connectivity, we can contact an Erlang instance on, let's say, the Linux side. Could be done limiting, but again, you have to write all the plumbing that goes with it for failover, redundancy, all that. Not a good option. Port, same thing. You set it up as a port, as if the Erlang server is like an Apache server, and you connect into it. Not a good option. I'm just trying to do things. I keep saying, quick to market. Okay, really important. I don't want to dick around and write code for this to work with that. Just not my option. The other option I was told is socket programming. It's the same idea. I've got to write all this extra stuff to work with Erlang, right? I'm not really interested in any of that, to be honest, from my point of view. And that's why this whole shift has changed because of C#, thinking I could use entirely everything in the Windows world and all the technologies that the Windows technologies give me. But when you look at Erlang and the power of it, you go, golly gee, I really want to work with Erlang. All right, and again, that comes back to also with that Windows stuff. You got the licensing, you got the updating, the maintainability. I mean, when you actually, it's one thing to talk about and think about it, and you go, it's cool. But when you start working with the Windows Server 2012 that I talked about earlier, the SQL Server, it's a lot of work. And to be honest, I'm still undecided on it. But with Erlang, it's just, I'm hoping a lot of that's taken away. Okay, and then the only thing I really want to talk to is my C# into my SQL Server or whatever database it will be. Okay, and again, that is for my front-end charting system, whatever it is. I've told you I'm sold on Infragistics, okay? All right, so let's go back to the server side. We've talked about Erlang. We've talked about Java connectivity in Erlang, the brokers into Erlang with Java, let's say, and let alone C++ or C. Then we get into the prototyping. We've talked to the pros and cons of each. We've not talked about Scala. Now, Scala is the same idea as FSHARP, but that sits on the Java virtual machine. It could be good, but I don't really honestly see the advantages with the other four options I showed you. R, Python, MATLAB, and Python. So, oh God, we're up to 45 minutes. 46 minutes. Wow. You can see how CompK this is. So, what we're looking at is definitely Java being for the broker, using Erlang as well as a communication hub into something I'm going to show you just to add extra confusion. This is fun. All right. So again, we have Python, R, Erlang, and Scala. I've talked about how I feel about F# and R. Awesome combination. We have Python, the same idea. Erlang and Scala. So I'm gonna do myself a favor and you guys a favor. Let's see. Oh, I'm gonna take out the word Scala just to take away a little confusion. All right. So let me bring back our system, all our components, right? So we've got MATLAB, I mentioned. We've got C# and F#. Okay, so now we've got everything covered. Let's talk about all our options that are at our disposal. So we've talked about MATLAB. Awesome language, awesome environment. The thing here is really appeals to me is to take whatever idea I have and let's just say co-generate it into C++, C, or HDL if I choose as an option to go, I don't know, hell's bells, I want to go FPGA. Well, guess what? MATLAB in itself gives us those options. Now, as you said, or I said, C or C++, guess what? That now opens up the world to me from here. No, down here. And I got to really work on my skills on this. Let me try this one. So I am going to point that C++ to here. It enables me to talk to any of these. Python, right? Through Python or something. This can be talked to through RCPP, Erlang. I know that can be done. I can't remember what one. They don't really care about Java, and of course it's native on these. So that's a cool part about MATLAB and co-generating into C++. Now remember I also said I'm just trying to clean this little thing up here. Okay, well, let's ignore these. All right, so that's a beautiful thing about MATLAB, and you can't really poo-poo options. And remember, I talked about Simulink as well, right? Simulink offers a lot of advantages. Okay, again, I mentioned those. Sorry about my typos here. Ugh, today's not my day. Should I just leave it? Maybe I should. Oh no, I just got to disappear. All right, so whatever. So there's options. Again, F#. Let's do that famous line. Well, you gotta like this. F# into R. Got that covered. C# we talked about. Cool, whatever. Awesome. So you can see the advantage of this side, this world. Correct? So let's move over to our wonderful side. So the client side is covered with the front end. All our options available for trading ideas and there's a ton of ways to go about it. But here's the interesting thing. Because I'm choosing now as Java for my broker APIs, I can then talk to pretty well. Let me just type them up over here. IB Oanda. Okay. Let's say I don't like Oanda. I go to Duca's copy for Forex. Okay. That's another good option. And then, of course, if I decide, I can go to Line. And that's all courtesy of Java. So I can talk to these guys on my broker side, on the Linux side. Very cool. So we got pretty well that covered, right? So that's the broker. Now comes the interesting part, the communication. We talked about Erlang and how we can build a sub-communication system between all this stuff, right? So now we have all these other options in the world of Linux. Now, I'm only talking about this now just for pure speed, okay? Obviously, at the end of the day, you want C++. Hey, let me just put it this way. Everyone thinks that C++ is going to make your code faster. That's BS. If you don't know how to optimize everything, memory management, all that, have the right APIs, libraries, whatever you do in C++ doesn't guarantee that you're going to have the fastest option. No different than if you write everything in Java. It has to be correctly designed and architected. Okay, that's something that needs to be addressed. So you got to be pretty good at what you're doing. Now let's talk about Python, R, and Erlang. I like R to connect me into F#, but I just don't see any real advantages of going that route. Okay, Erlang, I'm pretty well sold for the equivalent of that message queuing and the parallelism that comes with it. Very nice. You can't go wrong with it. Then there's Python. That's still a big black box. It's still a mystery that I want to dig into. And fortunately enough, I got a lot of cool people that can help point me the right way. So all this stuff is now kind of covered, okay? And it's just a matter of connectivity testing with different demo source files I'll play with, just see if I can get this to talk with that and vice versa. And then there is the famous database, right? The database is very confusing, okay? It's so confusing because this is a new area that I promise this will be the last confusing point of the whole thing. I'm just learning this today. Erlang has 3 databases. Amnesia, don't ask me about names, I don't come up with them, but it's called Amnesia, Couch, DB, and the last one's called React. I don't know anything about them, don't know the performance. Big mystery, but I can obviously do my research. I'm sure each one has their advantages. So that's a set of the advantages that you can add into this Erlang shell server, and it'll make maybe life easier if they are performance based. Now, tip that I got about Erlang is great for message queuing. With this stuff, not so good. Maybe that's true. So maybe these right off the bat can be a write-off. All right. So now we have further NoSQL options. Now I've studied these things, okay? Now, no SQL options, that brings us, let's just leave it the top 3 databases to choose from. We got MongoDB, okay? We have Redis, and we have Cassandra, okay? Good choices, all of them. Each have their pros and cons. Now before I continue, this is ideally what you want. You want your homegrown version of your own internal in-memory database that's fast. Many advantages with it. Speed, because you know the database really well. Concurrency and all that. But here's the big disadvantage. The big disadvantage is maintainability. Maintainability. I don't know. Well, you kind of get the idea. I'm a bad typist. I know that. I rush things through. So that's something I really don't want to consider because, only 55 minutes of blabbing here. You can see what else I got to worry about. If you are a one-man show, okay? That's one of the big, I guess you could say, turn-offs for me. Ultimately, that's what I would like to see, is a C or C++ homegrown in-memory database that can talk to all these little things, specifically Erlang, okay? So, what are my 3 options that are the next best alternatives? We've talked about the SQL and the Mongo, or sorry, NoSQL versus SQL. I'm going to have a webinar on this next Monday. I think it's the, whatever it is, but the following Monday, this date here, the 12th, December 10th. But this is a big one. Ultimately, I guess you could say the secret sauce of the whole thing with profitability is your database, especially for ticks and 1 minute bars, let's say. So SQL with Oracle, forget it. I played with it. Ugh. Not an option. It's fast, but just maintainability on that one, just pure hell. But SQL Server is not too bad. And the new one, 2014, SQL Server 2014, is quite nice. Here's why. Let me just pull up some interesting facts about 2014. Just put in MS SQL. So, OLTP 2014, OLTP. What does that mean? In-memory stuff. You can have your database, your tables, put an index in memory. It's bloody fast. And it's not too difficult to maintain. MSQL. But again, on this side I mentioned earlier, this is not as critical. It's not like do or die here. But it'd be nice for it to be fast, especially if you've got a lot of millions and millions of data points. So there's that. Now, if you've never played with SQL Server, the one thing I love about SQL Server is well, let's call it SQL Server SSMS. What the hell? SQL Server Management Studio. Look it up. This thing's bloody awesome. I was always thinking, wouldn't it be great? You have the language TSQL in it, as well as the native language of SQL Server. And here's the thing. Wouldn't it be awesome if you could take all your data and build maybe certain strategies in trading where you could have certain events hit in the database and trigger trades or events that could be fed back into your C#, let's say, or even FSHARP. This is powerful. I just, as an idea, this is awesome to do it that route. And again, you're back in the world of .NET, Microsoft, and Windows and all that. So that's another option down the line. People never talk about that, but I thought, wow, that'd be awesome to do. But these are some of the awesome things that you can do. And SQL Server Management Studio is very powerful in itself, very easy. You can generate scripts from it very easy, do pretty powerful queries. You know, I'm right now using this thing called, for my Postgres, Razor SQL, which is pretty good for the Postgres, but I'm wanting to move off Postgres. But again, we don't want to add confusion. That's for my AK-47 for those that were interested. Written in, of course, MATLAB, but we're not going to talk about that. But we're just talking about a high-level architecture system for the complete system from a technical point of view. Okay? So coming up to an hour now. Congratulations, I am blabbing a lot here. All right, so those are the advantages of SQL Server. Now, then we get into the added confusing part of all these different databases within NoSQL on the Linux side, the server side. All for this, we'll just leave it the term number crunching, right? So we have MongoDB, Redis, and Cassandra. Okay, Cassandra's written in Java. I played with it. It's fairly, at the time, it was fairly popular a few years ago. That seems to be falling off the radar. I'm not saying there's anything wrong with it, but trying to get it running in Windows can be done. Mongo's come a long way. This was the recommended database to go with. I would agree with that. Problem is, to connect Mongo into Erlang is a community-driven client binding. And I don't know, is that good? Is that not good? So that's kind of like the one drawback. Now, with Redis, the thing I like about Redis is they have a number of options available to talk into Erlang. Remember, everything's going to revolve around Erlang, and that looks very nice. Now, when you look at Redis talking into Python, that's another big advantage. And guess what? Redis can somewhat talk into C#, and yet Microsoft has also somewhat got projects enabling you to run Redis on Windows, which really can be done, but you know, that's why we do Linux, right? But that's not really a big deal, okay? Because I'm trying to keep everything here on the server side, Linux, okay? But Redis can talk nicely, it seems, to Python. Redis should be able to talk quite nicely with Erlang. Redis, I know as a fact, could do some wonders with Redis. And the cool thing with Redis, okay, let me just pull out my little guy here. Redis. These are the key differences between MongoDB and Redis. We talked about our brokers. Let's say I have 3 brokers. I have 3 different Java processes, servers, we'll call them, processes, whatever. They're listening to the markets on the broker side. So it's going to take that data and push it somewhere. Now it's going to push it into Erlang, and it's going to house it in one of these 3, Redis or Mongo. But if you've never seen any of my data solutions, and I've not yet talked about that, the data provider, IQFeed, the one I really like, it doesn't matter which one, but IQFeed, let's just say IQFeed, okay? IQFeed, on Tick, and you just watch any of my videos, okay? This is key, and this is all on Windows, okay? This is done through C#, okay? I have in my courses, I've got ways that you can take, let's say, IQFeed data through their APIs and feed them quite nicely into SQL Server. I've got code that does that, and I've demoed different ways. I've also done the same thing with Mongo and Redis, and this works fine. Works really good, actually. Okay. Sorry about this. I am in pain here. Okay. There you go. You didn't get rid of all these. Oh, there's a bug in this software. Free software, what can you do? Anyway, so we talk about in IQFeed going into SQL Server. Now, the reason I mentioned IQFeed on tick data, you can get 300 ticks per second that you're going to collect. So you got to have a really solid way to make sure that you can collect that data quite easily. And this is the key difference that I've noticed between Redis and Mongo. Okay, now this is why I'm looking for feedback. Give me your feedback as well. But the more, the better. Redis, I'm going to tell you, Redis is very powerful in concurrency for exactly this. So you got data coming in to write into Redis. Guess what? Redis is very powerful at that, and it's probably the best one I've seen. So that is a big, big selling feature of Redis. I've seen that in various other data comparisons online I've seen. Mongo is good as well. But the one old thing with Redis is that you could only house one instance of Redis on one server. Now we're talking about a few years ago, but the new version, the current version, as far as I understand, Redis now can be distributed among multiple servers. Okay, I'm hoping that is the case. Now, if that's the case, plus with the ability for my Redis to talk easily into Erlang and into, let's say, Python, that is going to be key and selling feature. Again, this is all hypothetical at this point. Mongo can do the same thing, but from what I see, there's just one API that enables me to talk into Erlang. But with Redis, don't ask me why, but there's 4 different options alone just for Redis to talk into Erlang. There's like 4 of them, 4 different choices. So you would think Redis, from a community point of view, from a maturity point of view, Redis is good at a client bindings. No different than what 0MQ offers. That's a big selling feature from my point of view, why I like Redis going into Erlang and into Python. Okay, with Mongo, you only have one option from MongoDB to Erlang. But again, Redis had like 4. Okay, that's one of the big reasons why I'm looking at Redis. Now, again, the only challenge I have with Redis is I'm hoping that you can house, quite literally, take that in-memory instance and distribute it among many different instances. If that's the case, Redis it is. I know you can do that with Mongo. Now I'm waiting for feedback on this, so anybody that can provide that would be awesome. So that's where we're at. And you notice I didn't talk about Cassandra. I just, from what I see, really the contenders in this space in the NoSQL just seems to be Mongo and Redis and some of these Erlang databases. But again, from what I've seen, from the powers to be, thank God that they exist in my life. I say otherwise. So let's talk about and recap. That's a lot. I've just talked 1 hour and 7 minutes. My God. All right. So we've talked about all the different options. Can all the options talk to each other language-wise, database-wise? And that's a big yes. So we got a big ding, 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 ding win there. Now let's just talk about Linux stuff. So let's say I want Python. Can I take my Python and communicate with Erlang? Yes, as far as I know. Can I take my R and communicate with Erlang? Possibly. Is that a dead problem? Is that a problem? May or may not. That's not a big deal. Can I take my Java for my Oanda, my IB, all those broker guys talk to Erlang? And that's a definitive yes. Okay, that's for the brokers. So you see where I'm going. We got Erlang with Python, Java with Erlang for that message queuing capability and with the concurrency. We talked about Erlang and what it provides. So that's a big win there. Now, for housing the ticks, which one are we talking about? I just said we're doing Redis. Is there a way for both Redis data bindings into Erlang? Yes, we do. Do we have data bindings for Python? As far as I know, yes, we do. Do we have data bindings that talk to R? Yes, we do, and I've played with them and I've seen them and they work great. Okay, so say Redis it is. Okay. I'm sure that, oh, and of course Java for the brokers if we choose. So now that we got all that covered, yay. Yay. Now, how do we build redundancy? Well, guess what? Guess what? There's 2 things that are really key here for redundancy and failover. Let's say this database dies. If it's Redis, it dies. We need to find ways for failover and redundancy. Now we can have dual Redis instances, okay, talking to these guys. Now again, because it's open source, it's free, we're not limited on how many licenses that, again, big old Microsoft provide that limit us. We do away with that with this solution on the Linux side, right? And we can scale it up to infinity to our heart's content. Awesome. Now, again, let me just show you something. I just said this. We can have two instances. So we can have Erlang instances feeding the same instance. We have Java, and these are coming in from the broker side. Again, if it's Oanda, Oanda, IB, Dukas copy, or whatever. Guess what? Because of the power of Java, we can easily feed that into this. Okay, this is into Redis, so we can easily feed that data into Redis, and I know from my experience we can do the same thing into SQL Server. Awesome. So you can see where I'm going. We have redundancy failover at 3 levels. Multiple instances of Redis in the database in memory, hopefully as fast as we can get it, as well as SQL Server for redundancy. And guess what that can be fed into? We haven't talked about that. But because we're feeding it now into SQL Server, guess where that can be fed into? Ooh, our charting system. Oh, joy. You can see how we can do that. Okay? And that's the infragistics that I talked an eon, stone ages ago. Okay, so that's all the Java and Redis instances on the database side. Yeah, I like that. But here's something else for extra redundancy. We can take these calls or data, okay, and we can feed them into, where's it going to? Erlang! Awesome. So we can have the advantages and the message queuing advantages for Erlang. That is awesome, right? And I've talked a lot about Erlang and what it can deliver. Now, that's just the data. And again, I've also mentioned IPFeed, who I like a lot too. That's my actual data source. So I will most likely use via their API for Java. Okay? Or I could use C# on the other end if I want. But this is kind of what I'm leaning towards for now. Using IPFeed, no different than these guys, if it's a Oanda, Dukas copy, or IB, and feed them both into NoSQL, the Redis instances, and if I want, I can feed those also into SQL Server. Cool, eh? All right, so that's kind of covered off pretty nice. Now let's talk about execution. So we have our algorithms and strategies living somewhere. Where will they be? This is kind of important. Now, depending upon how I author these strategies, we could do it on my girlfriend, and I've shown you the different options. It doesn't really matter on Windows or Linux or even Matford. And again, all these Linux options can be run on Mac if I really wanted to. I can feed them through the numerous options onto any of these components here. C++, let me just move this up here. So I can do it via C++, C, or Java from MATLAB, those exact options, okay? So we got that covered, or I could do it through the production server. Let's make sure I get that typed out here, MATLAB production server, if I choose. Okay, so that's one option. So we got that covered, right, through MATLAB production server. Now, just for experimentation, if I choose, I could do it through FSHARP if I want, back into the Linux world, but let's be practical, right? So that's another option, right? And that's one way to author it. And again, we have Simulink that I've also mentioned. We can co-generate into C as well. No different than C from MATLAB itself into these components here. So we have that covered. All right, so let's talk about Python and R. Now I've got some scripts done in R. Well, they're going to be sitting on the Linux side, so we got that. We also have RCPP as well that I've never really talked about. Because we're on the Linux side, we can use RCPP as another option. So we kind of have that covered. And again, it's nice to have these options and not have these limitations. That's why I'm doing this. And then of course we have the big granddaddy of them all, this guy, Python. Now I have no idea what Python comes into play. But again, I can use the same options here as I've shown you into Erlang. Okay, I've talked about PyErl, I think it was called, verification for somebody who's actually doing it. And I'm sure there's ways for Python to talk to Java, or if Java gets fed into Erlang. So we're all covered. So I could do maybe some scripts in Python and get them communicated through Erlang, and at the same time talk to my Redis, my instance of Redis in NoSQL. So we're covered. We're done. Just ideas. Thought I'd make a video. It only took me an hour and 16 minutes. Hopefully you're there with me so far. Awesome. Thanks for sticking around. But I just wanted to give you a general idea of the thought process on how I'm looking at all this stuff from an architecture level, from if it's going to be high frequency trading. We talked about it. We got it covered. From a database perspective, we got that covered too. We've got the charting, the awesome charting we can get through a front end like an Infogistics that I've mentioned as well. And then we got all the different analytical ways to build scripts, get them all talking to each other through, thankfully, Erlang and something like Redis. So, what do I need from you if you're still here? Feedback. This is really important. Feedback. Because I've got a lot of these components written. I've got a lot of components I've tested and run. I've done enough experimentation with this. So I know this is beyond theoretical, outside of the Erlang and the Python stuff. This should work. Let me know your thoughts. Thanks again for sticking around. Hopefully this will help out those. I'm sure I'm going to get some negative feedback as well. I hope not, but maybe I will. Who knows? But let me know what you think, and I'll talk to you soon. See ya.